Hello everyone, my name is Hemalatha. I am from Marri Laxman Reddy Institute of Technology and Management. I have been working in this institute from past 11 years. Total experience I have is 25 plus years of experience. I am from the Department of Physics. I'll be teaching you today's session, lasers and fiber optics, okay, which is there in the applied physics subject. Now, let us see what is the syllabus which is there in lasers. Now, lasers covers first, what are its characteristics? What is the importance of laser? That is the first thing. And in order to produce the output, we require some basic process. What are those three quantum process? Next, we have, in relation with the three quantum process, what are its Einstein coefficients and what is the relation related to these quantum process? Next, what is the basic principle which is involved in producing the lasing wave? That is population inversion. So to produce population inversion, we use one mechanism known as pumping mechanism. So next we have types of lasers. In that we have solid state laser, gaseous laser, etc. And then what are the major applications of laser? Okay, these are the topics which will be covered in lasers point. Next, these images, basic images, which are used in our day-to-day life. You can see the first image, which represents you where the laser light is used. As everyone knows that nowadays, in order to do the cataract operation, that is, one layer will be removed. That layer is easily removed by using laser light. That is one of the application in the medical part. Next, in drilling the holes, very hard materials you have. So how to drill the holes? For example, let us take diamond. To drill a hole for diamond or to cut diamond into two pieces, we use laser light. Now, nowadays, as per the technology implementation, this laser light is also used in implantation of tooth. That is, they are drilling the holes by using this laser light and they can implant the teeth also. These are the basic images which will explain you how laser light is used in our day-to-day life. Next comes, what is the basic full form? That is the acronym for laser. Laser stands for light amplification by stimulated emission of radiation. This is the full form of laser. Now, in this acronym itself, we are getting one word which is called as stimulated emission. Now, that is the basic process which is involved in the production of laser light. Okay, next. What are the main characteristics of laser? Because we are saying that laser is a very important light. So what are the characteristics it possesses? It has four main characteristics. First characteristic property is monochromacity. Second characteristic property is coherence. Third one is directionality. Fourth one is intensity. Now, if you see the images of this one, which are picturized on this slide, monochromatic. Mono means single wavelength light. Laser light possesses a single wavelength. As you take different colors, it has different wavelengths, but it possesses a single wavelength light. When you take a white light and when you allow it to pass through a prism, it splits into 7 different colors. But laser light, when you allow it to pass through any object, it emits a single color light which possesses a single wavelength. That's why it is said to be a monochromatic light. Second one, coherence. Coherence is a property where we can relate amplitude and phase. That I'll tell in detail in the next one. Next, directionality. If you compare this property, this characteristic with the normal light, that is the normal bulb which will be used in the daily life, when you switch it on, it gives light throughout the room. But whereas laser light, wherever you focus, wherever you point that light, it gives brightness at that particular point only. That is the basic difference between a laser light and a normal light. That is, normal light is a conventional source. That conventional source, when you compare it with laser light is highly directional one because it travels in a single direction only. Next, intensity. As we are saying that light is focused at a single point, that is nothing but the concentration of atoms which are present is focused at a single point only. So that's why laser light is said to be highly intensified light. Next, we have the three basic phenomena. That is, the first basic phenomenon is absorption. First basic phenomenon is absorption. In order to explain this absorption, best example before explaining this one, I'll tell you. You take a sponge and some water is present on the floor. Now, in order to wipe that water, we are using this sponge. Put the sponge on that water. The sponge absorbs. Similarly, in the laser light, what is absorption? In order to explain absorption, let us take two energy levels. Let us take one solid material which is consisting of some energy levels. So let us take the basic energy level system which consists of two energy levels. Now let us name them. That is, the number of atoms present in lower energy state, let us take it as N1, and the number of atoms present in the higher energy state, that is excited energy state, let us name it as N2. And the energy corresponding to N1 is E1, energy corresponding to N2 is E2. Okay, in any type of system, the basic phenomenon is lower energy state, the atoms will be present. The atoms will be present in the lower energy state. Now, these atoms, they want to get excited to higher energy state, but they are not having sufficient energy. Now, to give them energy, we are using external source of energy. And that external source of energy is coming out is taken in form of photons. As everyone knows, energy of a photon is E is equal to h nu. E is the energy, h is the Planck's constant, nu is the frequency of radiation. Now, if such type of particles which are represented by this way, and if such type of particles, if they are allowed to incident on the lower energy state atoms, now these atoms which are present in the lower energy state, once the photons are incident, they absorb the energy. Now these atoms become more active, and these atoms, they get excited to higher energy state. Now this process, we call it as excitation process. Now, as the atoms are absorbing the energy from the photons, this process is called as stimulated absorption process. Okay, is it clear? Now, the next process is the spontaneous emission process. Spontaneous, as everyone knows the meaning of spontaneous, continuously. As you come across one session in your English which you call it as jam session, just a minute, where you will be given a topic, you will be asked to speak continuously at that instant itself. That is nothing but spontaneity has to be maintained. Similarly, in this also, we have the second process is the spontaneous emission process. Now, what is this spontaneous emission process? So, in order to explain this spontaneous emission process also, let us take the same basic energy level system with number of atoms as N1, N2, corresponding energies as E1 and E2. Now, where are the atoms present? As the atoms have got excited to higher energy state, they are present in the energy state E2. Now, these atoms, once they complete their lifetime, mean lifetime. Now, what is meant by mean lifetime? Each and every atom which is present in the higher energy state, they will be staying in this higher energy state for a particular period of time, that is 10 power minus 8 seconds of time. That means how many number of atoms that are jumping to the higher energy state, these atoms in the higher energy state, they stay for a time of 10 power minus 8 seconds. This particular time is called as the mean lifetime. Once the atoms completes this time, 10 power minus 8 seconds time is completed, automatically by themselves without using any external energy, the atoms by themselves on their own, they return back to the lower energy state. This process we call it as the spontaneous emission process. Once again, I'm repeating this process. Now, in the first state, atoms have absorbed the energy. They are in the higher energy state. Now, the atoms which are present in the higher energy state, they have certain mean lifetime. That mean lifetime for every atom in the higher energy state is 10 power minus 8 seconds. Once this time is completed, automatically by themselves, without using any external energy, they get de-excited to lower energy state. Now, in this de-excitation process, they are releasing photon because they have absorbed the photon. So that photon has to be released. This process we call it as spontaneous emission. Spontaneously, once their lifetime is completed, they are coming back. Now, the third process is stimulated emission, where laser light, in the acronym for laser, we have mentioned this one, stimulated emission. Now, what is the stimulated emission? For stimulated emission also, we use the same diagram for the spontaneous emission which we have used. That is, the atoms are present in the higher energy state. Now, these atoms, after getting excited to higher energy state, they don't want to stay in the higher energy state. They want to get de-excited to lower energy state. So, in order to get de-excited to lower energy state, we are supplying the external energy again in form of photons, which is having an energy h nu. These photons are supplied on the higher energy state. Now the atoms which are present in the higher energy state, by absorbing this energy, they undergo de-excitation to the lower energy state. This process is called as stimulated emission. Stimulation, we are giving heat, we are supplying energy from the external source in form of photons on the higher energy state, and the electrons or the atoms present in the higher energy state, they absorb this energy and they undergo de-excitation. This process we are calling it as stimulated emission process. And in the stimulated emission process, they will be releasing 2 photons. Whereas in spontaneous, only 1 photon is emitted. Whereas in case of stimulated, 2 photons are emitted. That means 1 photon to go to excited state and another photon from the excited state to undergo de-excitation it has used. So 2 photons are emitted in the stimulated emission process. So for every laser system, these are the 3 basic quantum process which are involved to produce a lasing output. Now, in relation with these 3 quantum process, we have the coefficients which is called as the Einstein coefficients or the relations, where we will be relating one type of quantum process with the other process. So in this also we use a 2 energy level system, the same type which we have used in explanation of the 3 process, the same energy level system consisting of N1 and N2 number of atoms related with E1 and E2 energies. Now the atoms are present basically in the lower energy state. Now, once you supply energy for the lower energy state atoms, they are absorbing and they are getting excited. So that is the first process which is called as stimulated absorption process. Now, in this process, what we see is on what factors does the absorption process depends. Now, the factors on which the absorption process depends are, first factor is it depends upon the energy, external source of energy. That is, it depends upon the stimulated absorption depends on, first factor, it depends on the amount of energy. Let us represent the energy in terms of a rho of nu. That is, how much amount of energy that is given in form of photons to the lower energy state atoms. So it depends on the lower energy state atoms. Second, it depends upon the number of atoms present in the lower energy state. So the stimulated absorption process depends on 2 factors. First factor is it depends upon the energy, how much energy you are giving. Next, it depends upon the number of atoms present in the lower energy state. So that means we can say that these two, that is the stimulated absorption, is proportional to rho of nu and n1. Now let us remove this proportionality constant, introduce one constant which is called as B12 rho of nu, B12 rho of nu n1. That is, what is B12? B12 is called as Einstein coefficient for absorption. B12 is called as Einstein coefficient for absorption. Why we are writing it as B12 is the transition is from lower energy state to higher energy state, that is from first energy state to second energy state. That's why we are calling it as B12. So this is the first coefficient, first absorption coefficient which we have written. Now the second process is the spontaneous emission process. Now what is spontaneous emission process? Spontaneous emission process is very simple. The atoms are present in the higher energy state. Now once their lifetime is completed, they naturally get de-excited to lower energy state. So in that process, on what factors the spontaneous emission depends? Now the spontaneous emission depends on only one factor. That first factor it depends upon is the number of atoms present in the higher energy state. Now here you may get it out why madam is not writing energy, because here no energy is required for de-excitation process. Once lifetime is completed, automatically gets de-excited to lower energy state. So hence it depends upon only the number of atoms in the higher energy state. Now remove this proportionality constant, introduce one constant which is called as, introduce one constant which is called as A21. Introduce one constant which is called as A21N2. Now what is this A21? A21 is called as the Einstein coefficient for spontaneous emission. As we are in the spontaneous emission, now the atoms are getting de-excited from higher energy state to lower energy state. So they have used it as 21. So A21 is called as the Einstein coefficient for spontaneous emission. These are the two quantum processes which are occurring. And the third quantum process which is occurring is the third process which is called as the stimulated emission process. Now what is this stimulated emission process? Stimulated emission process is the atoms are present, the situation what we see is the atoms are present in the higher energy state. Now these atoms, they want to get de-excited to lower energy state. So in order to undergo de-excitation, they require some external energy. Now this external energy is supplied again in form of photons on the higher energy state. As the atoms are present in the higher energy state, we need to supply the external energy on the higher energy state itself. Now once the atoms, after their incident particles are incident on the higher energy state, they absorb the energy and they get de-excited to lower energy state. So this process we are calling it as the stimulated emission process. So on what factors does this stimulated emission process depends? Stimulated emission depends on two factors. First factor is it depends upon the amount of energy, because we are giving energy to undergo de-excitation. Second process, it depends upon the number of atoms present in the higher energy state. So finally what we can write is it depends upon rho of nu and n2. Now I remove this proportionality constant, introduce one constant which is called as B21 rho of nu and n2. Now this B21 is called as Einstein coefficient for stimulated emission. As the de-excitation is taking place from second energy state to the first energy state, so they have represented it as B21. So B21 is called as the Einstein stimulated emission coefficient. Okay, so we have come across the three processes: quantum process, absorption, spontaneous emission, and stimulated emission process. Now the next is at thermal equilibrium position, when all the atoms are in the lower energy state, let us say that the upward transition will be equal to downward transition. Now what is upward transition? Upward transition is absorption. Absorption is called as upward transition. Now this upward transition must be equal to downward transition. Here there are two types of downward transitions taking place. One is spontaneous emission, second one is stimulated emission. So now the upward transition is absorption process and the downward transition is stimulated emission plus spontaneous emission. Now, by taking this equation, we can derive the Einstein coefficients. That is nothing but, now first absorption process is what? B12. B12 rho of nu N1. This is equal to, what is the downward process? Spontaneous emission, A21 N2 plus B21 rho of nu N2. Okay, now you can see this equation. On this, both the sides of this equation, rho of nu is present. So I bring this B21 this side. So B12 rho of nu N1 minus B21 rho of nu N2 is equal to A21 N2. Okay, simple equations. Now take out rho of nu common. Rho of nu is equal to rho of nu into B12 N1 minus B21 N2. This is equal to A21 N2. Okay, now express this equation in terms of rho of nu. Now, in order to express this equation in terms of rho of nu, let us write this equation like this. Now, rho of nu is equal to A21 N2 by B12 N1 minus B21 N2. Okay, now express this equation in some simpler forms. Now, what are the simpler forms? Is very simple equations. Numerator I want to remove N2. So, in order to remove that N2, what I am doing is, I am multiplying and dividing numerator and denominator by N2. So, I get the equation as rho of nu is equal to A21 N2 by N2 by B12 N1 by N2 minus B21 N2 by N2. This is the equation which we are getting, multiplying numerator and denominator by N2. So this N2, this N2, this N2, this N2 will get cancelled. You are left with the equation A21 by B12 N1 by N2 minus B21. This is the equation what you are having. Now I want to express the numerator. I want to express this equation in terms of B12 by B21. So in order to express that one, I am multiplying and dividing the numerator, numerator and denominator by B21. That is A21 by B21 by B12 by B21 into N1 by N2 minus B21 by B21. So this gets cancelled and you are left with 1 minus 1. Okay, so rho of nu is equal to, that is the energy, is equivalent to A21 by B21 by B12 by B21 into N1 by N2 minus 1. Now this is the equation for energy density. Now let us take these equations. Now let us relate these equations with, we wanted to write this, get the value of N1 by N2. In order to obtain the value of N1 by N2, Max Boltzmann, one scientist, Max Boltzmann, he has given the ratio of population. Now let us don't use the word number of atoms. Let us introduce a new word which is called as population. Population which is similar to the number of atoms. Now, according to Max Boltzmann, what he said is ratio of populations, that is N1 by N2, he called it as the ratio of populations. So according to him, what he gave is N1 by N2 is e power E2 minus E1 by kT. This is the equation which he has given. Max Boltzmann has given this equation. So that is nothing but, generally we write it as N1 is equal to N0 e power minus h nu by kT for N1, and the second for the N2, N2 is equal to N0 e power minus h nu by kT. Now let us write this equation itself as e power minus E1 by kT. Next, let us write this equation as this equation N0 e power minus E2 by kT. Now, if I want to write the ratio of these two, that is N1 by N2, if I write this one, this N0, N0 will get cancelled. You are left with, this is in the denominator. So I take to the numerator, you will be getting e power E2 minus E1 by kT. This is the same equation what we have written in this one. So N1 by N2 is E pi E2 minus E1 by KT. Now what is this E2 minus E1? As per the first part, we say that, as you know that, as we have written, the energy of a photon E is equal to h nu. This is the general equation. Now if I write it in terms of E2 minus E1, here I take it as h nu. Now I write this equation as E power minus h nu by KT. This is the equation what you will be getting. Now take this equation, substitute in the energy density equation. Now if you substitute in the energy density equation, that is rho of nu is equal to. So rho of nu is equal to, we have got the equation A21 by B21 by B12 by B21 into N1 by N2. In place of N1 by N2, I write this as, this is not minus, this is plus. So it is E power h nu by KT minus 1. This is the equation which you will be getting after this one. Now, there are two scientists, that is, there are two different types of laws, radiation laws. One is Planck's radiation law. What he said is, according to Planck's radiation law, the energy density equation is given as 8 pi h nu cube by c cube into 1 by e power h nu by kT. This is the equation what according to Planck's law has been given. Now relate these two equations. If you relate these two equations, numerator, numerator, denominator, denominator, you will be getting the Einstein coefficients. That is, you will be getting A21 by B21 is equal to 8 pi h nu cube by c cube. Then this is the first Einstein coefficient. The second Einstein coefficient is, you will be getting B12 by B21. B21 is equal to, this is e power h nu by KT minus 1. This is also e power h nu by KT minus 1. So you will be getting 1. So what he says is, the number of transitions which are taking place will be always equal to the number of downward transitions. The number of upward transitions, how many number of atoms are jumping to higher energy state, that many number of atoms will again return back to the lower energy state. So these two equations are called as Einstein coefficients. Okay, so with this, today's class is completed. I'll close the session today. In the next class, I'll be explaining you about the population inversion, then what are the pumping mechanisms. Thank you.